Right, for no good reason. Just give Ben Buchanan a bit of help. Right, so I've been doing stuff on the web for many years, and how we often think about the web is we think about it as a document medium, and obviously we're moving much more towards more application-like experiences a lot of the time. But I still think we sort of live in our little sandbox of the screen and the user interaction, and what I'm really excited about when it comes to web technologies right now is how we're getting more and more access to underlying device APIs. We're seeing, there's only one sector of the PC market, if you don't include tablets, we're going to go, is the only one that's actually growing is the Chromebook, right? Which is a platform entirely driven by web technologies. If you look at Windows RT, you're looking at an API that's a first-class API on Windows for building applications, native applications using web technologies. If you look at BlackBerry, they've invested enormously in exposing all the underlying device APIs directly to applications built with web technologies. I mean, this is a trend, I think, and obviously on other platforms that we won't mention because they don't like the web as much, you've got PhoneGap, right? So what we're seeing with web technologies is the ability more and more to reach into the device capabilities. And of course, I think probably the leading light in this area to some extent right now is Firefox OS, which is essentially a 100% pure web technology driven experience where all the underlying device APIs are exposed directly into web technologies. So what I like doing is doing little experiments and seeing what I can do with these technologies. So when we first moved to our office where Web Directions is down in Surrey Hills, we had a tenant there who had got an old Mac, one of the really old iMacs, which had a camera in it, and had written a little app that would basically detect motion, and it would send an email of a screen capture of the camera if there was some motion after hours. Right? And it used to fire off, and we'd see who was actually working late at night. Right? Well, about 3 a.m. like something like November last year, someone broke into our office and stole a heap of stuff. And unfortunately, this person had moved out. So we didn't have any record of this, what had happened. But it did get me to thinking, can we use some old bit of web, hardware that's floating around to build something like this? So that's what I'm going to show you what I did. Right? So what we're going to do is we're going to first detect motion in the vicinity of a device. So we can use two things to do this. One's called device motion, and one's called device orientation. So each of these things we're going to look at briefly as we go. Once we've detected some motion, we could fire up a video camera, because many of these devices have cameras now, right? So we could fire that up, and we can use a small part of WebRTC called Get User Media, and that allows us to get an input from the video camera or the audio input device that our laptop or phone and a heap of other stuff is actually getting. What we can then use is the canvas element to capture a screenshot from this live video feed, and then we can store that locally on local storage. We can send it in an email. We can use WebSockets to send it in a server that went off to someone else, right? So there's a heap of stuff we can do. So let's have a look at some of these components, and let's build this particular device in about 10 or 15 minutes. So the first thing we're going to do is detect motion. And what you may well know, and what we probably should know, is tablets and phones have gyroscopes and accelerometers in them that can detect how the device is oriented in three-dimensional space and how it's moving in that space. What you may not know is certainly some laptops also have gyroscopes in them that were actually originally there to detect motion so that they could shut off hard drives if you drop the device. So for example, MacBooks have had that for many years. Interestingly, the MacBook Air doesn't have it anymore, right? So what I'm going to talk about now doesn't work with MacBook Air, but it works with pretty much every other MacBook, right? And so what we can do is we can use or device orientation, device motion to detect whether a device is in motion and then do something as a consequence. Now we're probably thinking about all the things we do. People make games and they kind of have undo gestures, but in fact this is, I guess, trying to show you there's a heap of things we can do once we can determine the context of the device. And one of the things that we can determine of the context of is it moving, right? And what about the movement is basically at the moment as I'm walking around, these devices are in motion. They're detecting that motion quite substantially. If you were looking at the readout, you could tell that motion was going on. And we could use that to trigger other things going on. All right, so that's the first thing we're going to do. So we'll look at device orientation, which is the lowest common denominator. This works across any device. So pretty much any device that supports either of these things. Everything that supports device motion will also support device orientation. So basically, the window object in devices that support this receive an event, device orientation event. They also receive device motion events if they support that, right? So we just our standard. If this is supported, we're going to add a listener. We're going to add this method called orientation handler, this function orientation handler that is going to fire when the device receives an event. Now these events are fired hundreds of times a second, and something to be aware of because the more you process them, the more battery life you use, and you can very quickly turn your phone or your laptop into a very warm, short-lived device. So that's something to be aware of there. Right? What information is sent with this event? Well, we get information about the orientation of the device in 3 axes. So we have a z-axis which comes directly up through the keyboard. So imagine the keyboard as being the canonical aspect of this. So obviously with a screen device which has a virtual keyboard, the screen and the keyboard are the same thing, right? So if it's directly out of the device, that's our z-axis. Through the device in this way, across the plane of the device, we have the x-axis, and sort of up from the keyboard through the screen like this, there's the y-axis. There's some more subtleties to this I don't want to bore you with. It doesn't always work exactly in an intuitive way. However, when you rotate the device, x, y, and z don't rotate, right? So the x, y, and z are relative to the device, not to the frame of the Earth, right? And then we can detect motion or orientation in these 3 axes, right? So if we are moving through the x-axis, basically we're tilting it forward and back, we're getting a positive value between 0 and 180 degrees as we tilt it forward, and a negative value as we tilt it back. If we tilt it to left and right, if we tilt it to the left from 0 to 180 degrees, and tilt it to the right from 0 to minus 180 degrees. And then the z-axis, which comes out of the device, as we tilt it around, that's called alpha. Now, alpha is actually not supported in Chrome, which is the particular browser we're going to worry about. So we're not going to look into that today. But basically that's the rotation around an imaginary line that comes directly up through the keyboard of the device. And I say keyboard because if I'm using this laptop, it's actually not the screen that's important. It's actually where the keyboard is, right? Probably enough detail there. So what we'll need to do in our event handler is we'll get the current beta and gamma. As I said, Chrome doesn't support alpha. The truth is if something's moving in even one dimension, it's moving, right? It'd be very, very difficult to rotate a device in one plane and not at all in the others. So basically it's a good rule of thumb that if it's moving in one plane, it's moving, right? So what we'll do is we'll get the beta and gamma, right? And then we'll save that beta and gamma. And the next time we get an event, we'll look at the differential between the two. We'll just subtract the number of degrees. So each of them is a degrees. So we'll look at how they've changed in say, 100th of a second, or a 50th or a 20th. You just set a timeout period, and it doesn't have to be that short. Anywhere between kind of tenths of a second generally works pretty well. And if this value is greater than some threshold, say I generally find between kind of 0.5 and 0.7 of a degree, pardon me, then we'll say we've moved, right? So let's have a look at what that actually looks like in code. I love being able to show stuff like this and people aren't getting afraid, right? I should be afraid because I'm showing you a whole room full of people my stuff, right? Any bad coding is purely for the purpose of simplifying, right? For example, I actually don't, it doesn't matter. I won't explain why I wouldn't actually run it like this most of the time. But so we've set a threshold and we've said, right, it's currently not in motion. We get the beta change, which is our current orientation.beta. So the event, the orientation data event, has an alpha, beta, and gamma. The dot beta is the rotation in the beta, and the dot gamma in the gamma. And we subtract our most recent beta and gamma from that. You can see that our very first event will decide that it's in motion, because we're going to have to start with some arbitrary value for last beta and last gamma, like 0. And then we just get the absolute difference of either of those, right? So we say if either of those is greater than our threshold, either positively or negatively, we are in motion. And if we're in motion, we do something, right? We're going to do something, and that's the bit we're going to get to next. And then we store our last beta and last gamma. Yes, they're global variables and whatever. It doesn't matter. This would be 4 screens of code that you know what I mean. So don't do this at home. This is just to give you, because everyone's like, but you use the global. Well, they do it. They don't. They don't do it. All the time. You know how hard it is writing books? So part of the theme of tonight is originally Craig asked a number of people who've written books to come and speak about something. And so I guess we all three of us who've written books, but you haven't actually written a book, but you've done a heap of, published a heap of stuff.
Yeah, I wrote a bunch of chapters.
Yeah, right. Yeah, but again, like you get all these.
You
put
put more chapters together.
That's it. It becomes a book when you put it together. The thing is, you do this and you work really hard and you put it out in the world, and then people quibble over the smallest thing, and they're like, "No, thanks." You have to be nice. It's like, "Thanks very much for that." Yeah. So what I'm really saying is, don't criticise my code. It'll be pain in the ass problems. Right. So what we're going to do now? Okay, you know that bit where I said something happens. Right here, this is like, something happens. We're going to get to the something happens bit now, because this is the interesting part. So there's this thing called Web Real-Time Communications, RTC. It's really amazing, and Damon, who was flagged before, oh, there he is over there now. So he's at NICTA along with Sylvia Pfeiffer, who is one of the editors of the HTML5 spec and a genius in this whole space. So we're kind of, Australia is doing a lot in this area, and it's an amazing technology. It essentially means you can do things like Skype in the browser with no plugins, right? You can have peer-to-peer communications, you can grab the audio, you can grab the video, you can open up multi-channel communications between endpoints, and with some fudging in the middle, basically get them all to talk to each other, right? But we're going to use a tiny part of it. So don't think that WebRTC is all just about grabbing a video stream or an audio stream. That's just a small part of it, but it's a cool part of it. So what we're going to do is we're going to use get user media, and that's part of the navigator object. Right, so our navigator has a thing called get user media. That's a method that it has, and we give it 3 arguments. We give it an options callback. We're going to look at each of these in a second. We give it a success. So it gives an options object a success callback. So when we got user media, it's going to come back to us and say, "Hey, I got your user media." Or if we fail, it's going to say sorry and call that function. I love callbacks. No, I don't really, but anyway, that's how it goes. So options are this. You can basically, by default, the options are false, but I'm just showing you, there are only 2 options. If you want audio, you have audio true, video true, so you can get either, both. Probably wouldn't want to get neither, I guess. I'm sure there's a use case for not getting either.
Get user media. I got you nothing.
Yeah, I got you nothing. So that's actually sometimes how the W3 writes test cases. It's like, well, passed. All right. So anyway, in this case, we're not going to worry about the audio, but that might be worth thinking about. But in this case, we're just going to grab the video. All right. Now, get user media is asynchronous, hard to sync, right? Because you'll see what in a minute. But basically, getting that media, the device won't just simply fire up its camera and start taking video. You can imagine why that's not a great idea, right? So the user has to input to agree to this. So we've sort of seen this with Flash for a long time. Flash can't just like open up a camera and get the video stream in the same case. So basically, it's got to be asynchronous. Because obviously it doesn't want to block on the I/O and everything else while it's waiting for someone to say yes, right? So we give it these 2 functions. We've got a callback function got user media and a function get user media. So here we go, put it all together. So we get navigator.get user media. We'll give it our options to say give us a video, but don't worry about the audio. If we get it, call this function. If you don't, call this function. Right, so we've set it all up. It's really simple stuff. Are we going to have a promise-based, futures-based version of this?
I hope not.
Right, there you go. Right. Yeah, there's a bit of debate.
It's open to the discussion.
Yeah, there's a bit of debate. If you're familiar with the direction a lot of the DOM APIs are going, now there's the idea that we're going to have a standardized promises system that all DOMs that return things asynchronously are going to return a standardized thing. I think they're calling it futures at the moment. And because WebRTC is so close to the final call and that's not in there yet, I think that's going to avoid that. But anyway. If it succeeds, because I'm not going to worry about it failing.
Microphone's off.
Sorry? I've run it out of batteries. Is it off? Yeah. It's gone red. Is it just say, shut up, John?
Did you get a call back?
I did. No, I did. There was a call from the back. Here we go. I'll keep shouting. You want me to keep shouting? Let's see this keep. I'll keep going until Sharky quits up. So, when we get the success callback, it gives us a stream object. And that stream is just sort of a reference to a thing, right? It's just the stream thing over there, right? So what we do with that stream is we want to put it in a video element. See, it's all coming together. There's all bits. We're pulling it all together. So what does a video element take? It takes it can do 2 things. It have a source attribute and or source element. So we're just going to use the attribute for the moment. So basically, we are going to create a URL for the video stream. So people played a little bit with files and blobs. Basically, we can use this window .url object to create an object URL for a file or a blob. In this case, we're creating for a stream. So essentially, it creates this anonymous, one-time only URL. We can't save it in local storage and read it back later. We can't send it in a message to another window or tab. This is a URL-based reference to that stream for the life of this window and this document only, right? So basically, a lot of the stuff's like about security. We don't want to be able to create these things and then sneak them off. So we've got a video stream we can sneak back later when the user opens a window or whatever. All right. Okay. Oh. Very good. Thanks very much. I have to stop shouting as much now. All right. So here's what we do: is we create this variable called video source, which is just one of these URL objects using create object URL. And we just make that the source of our video. So our video element is just a video that's in the HTML. We use query selector to grab it, and then we give it that video source, right? So it's essentially the same as giving it any URL, a string URL effectively. In this case, we're giving it this URL object. Oh, there's Dot again. All right. Okay. I don't know. So, don't believe me? Well, okay. Let's see this in action. You know, proof of the pudding and all that is the technology is already letting us down. Right, so what you can see, by the way, is I've just opened an example page. Up the top, it's telling me that the page would like to share the camera, and you have to agree to that. All right? And if you've got multiple cameras, like USB-based camera and other kind of cameras, it will give you the option to choose between those. So I'm just going to share the selected device, but I also have to manually, this is in Firefox, as you probably tell, I'm going to have to manually start that video going, although I can probably fire an event to that. Anyway, so now you can see, here I am, just proof of the pudding. So there's no plugins, there's no flash, nothing. The browser is now capturing my video and showing it to you directly.
Like the Instagram version.
This is that's it. We've got, it comes with free filters.
Yeah.
All right. So so what have we done? So far we've detected the device orientation. When we've detected some sort of movement in our vicinity, we've turned on the video, and obviously you've got to worry about, you probably wouldn't want to do that because it would require some sort of intervention by a user, so you probably want it all set up ready to go in advance. But anyway, just stepping you through all the steps, we've got our user media, and the next thing we want to do is we want to capture a screenshot. So at the moment, basically it's just playing a video, right? You've got a video element, it's got this stream, it's like streaming anything, right? It's like streaming any sort of content. But we're going to take a snapshot. So we're going to use the HTML5 canvas. So there's all these things, maybe you didn't know they did all this cool stuff, right? We have this stereotypical ideas of what each of these bits of technology can do for us. But it's only when you start playing around with a new idea, like none of this really occurred to me. I just had this idea, I reckon I could do this with WebRTC. I was out for a run, and I had that idea. I came home and I started, because that's why I do my best thing. It's true, I do. Out for a run, came back, and I started playing with it. And it really, a lot of the stuff I'm playing with, I hadn't really thought about using Canvas in that way. I hadn't really thought about using the URL object in that way. So I really recommend, if you ever get a sort of slightly curious idea about what you might be able to do with web tech, run with it. Get a simple thing and play around with it, because I think that's a great way of exploring some of the sort of nooks and crannies of web technology. So what's going on here? So we've also got a canvas element in the page. And so we use what my all-time favourite bit of the DOM, which is query selector. In and of itself just completely gets rid of the need for jQuery, and that's a good thing, right? So query selector pretty much just replaces jQuery, right? You give it any, if you haven't seen query selector at all, it's just like $, right? Except it actually doesn't take you like 250 meg download to use. Right? You have to worry about online or anything. It's just there. It's in the browser. It's free. It's in the DOM. Right. So we just give it a selector, canvas. Feel free to heckle. I'll just avoid it. Right. Now, no, you're too smart. So what we do is now canvases. If you haven't played with it, canvas is weird. It's an element that can have context. And if you play with WebGL, you know there's a 3D context that WebGL is. But in fact, most of the time we work with a 2D context. So here what we do is we get its context, and what we're going to do is we're going to take the video element, so we've just got the video element, and we're going to draw an image into the context from the video element. So you've probably seen Canvas draw image, or basically you draw an image from an image element. You can't give it a URL. right? You've got to give it an image element currently in the DOM. In this case, we're giving it not an image element, even though it says draw image, we're giving it a video element from the DOM. Right? We don't give it the blob, we give it the video element itself. And this 0, 0 is just saying start in the top left-hand corner of the canvas. There's a heap of stuff you can do there as well. So basically what we're doing is at any given time, we're grabbing a screenshot and we're drawing it into the canvas. Now why would we want to do that? Well, once it's in the video, it's kind of like in its own closed little world. This is a way of grabbing content out of the video, and now we could do things like a pixel map of it. Right? And then we could manipulate the pixel map. Right? We could posterize it if we weren't already posterized it. Yeah. But more importantly, we can capture it as a file, right? So that's the next thing we're going to do. We've captured it as a screenshot. So let's show you let's actually just prove that this actually works. Right? So here's our next version. Again, the next time every time a page or a tab, even at the same domain, even pretty much the same URL, asks for that, it asks for it, right? It's not like give me 24 hours worth like geolocation. No. Every single time you want to open a stream, it's going to ask you, right? So we're going to share that. We're going to do that, and then what's doing this is at the moment I'm just polling for every second just to make it simpler because Firefox, which I'm presenting from, doesn't actually support device orientation. But basically every second it's just grabbing a screenshot there. So you can see here, I'll come back. So you can grab that screenshot and then you can do stuff with it, right? You can email it to someone. You could have open a WebSocket, as I said, and send it to someone. What was that one? Yeah, every 10 seconds.
Here's me now.
That's it. I'm sure there are entrepreneurs in the dodgy areas of the world at the moment thinking about how they can use this technology, which is actually part of the reason why there's so much concern about it. And I'm sure Damien can. If you read the spec, if you read everything around this, there's a lot of concern to think about how it can be essentially how to stop it being misused. And we've seen examples of this, people, basically being spied on in all sorts of ways. And, the last thing you want is a technology like this can just over the web, right? This is a web page, right?
And I'm not going to heckle.
Right.
But there's two interesting points. Is
yeah.
that if you serve it over HTTPS at the moment, you don't get prompted for security, it just starts working, which is interesting.
Is that in the spec?
I don't know.
All right, okay. So servo HBS, no asking. Right.
No asking.
Which browser? Well,
Chrome at the moment.
Firefox.
I haven't noticed.
Does the light still come on?
No. I just thought it was by design. HTTPS. Oh, what can happen?
Yeah, that's it. Oh, it's a secure connection. They must be trustworthy.
The other interesting.
It had a key.
Yeah, it's all good. They asked for something.
It had a lock, officer. Keep going.
The other interesting thing is that you don't actually need to put the canvas in the DOM. If you don't want to, you can create an off-screen canvas with the create element, and it will work.
Oh, of course. But it's in the DOM, right?
No, it's not.
No, when you create element. Oh, okay. So what you say? Yes, I see what you're saying. You create the element, but you're not actually giving a parent element, right? Okay. So you've created. It's
It's a minor.
Yeah. That's right.
It's useful to know.
But my point is, you have to give it an element. You can't give it. You can't give it a source URL or a blob or a file. You've got to give it an element, right? Which it sort of makes it pointless anyway. But anyway. The other thing too, and this works with images, and I assume it was video. If the image, and I'm assuming video, I could be wrong. Please correct me. If the image is the same domain, you can grab the pixels from it. If the image is not the same domain, you can't grab the pixels out of it. Now it gets really interesting if you draw an image in a canvas, some of it you've drawn yourself and some of it's the image you projected into, you can get the pixels that you drew, but you can't get the ones for the image.
I never even found that.
Yeah, no.
I knew that it was, I thought the spec set was marked.
The whole thing? I think it only marks the
only
pixels.
once it was an external image was drawn in.
Oh, we'll have to check that one. But anyway, it's worth knowing that if you're on the same domain, you can grab what I just did. And you can still display it on the screen regardless. It's just trying to get the pixel map out of there. And can you get a data URI?
No.
Right. So this has got all the
You can get data URI out of the canvas if it's still the same domain.
different. You can't do a different domain, right?
Once it's different domain,
Right. So
it's like
what?
you can't get it.
Right. So whatever I'm doing here, you've got to be all of it on the same domain, right? Just to clarify. No, this is kind of a technical point. Anyway, I know I'm dragging the chain here. Right. So what can we do with it? There's a heap of stuff. I talked about that. What I am going to do it very briefly, just because not to show off local stories so much, but to actually show you another quite cool thing about Canvas is we can just grab a data URI. You can grab a pixel map too, but data URI is really simple stuff, right? And then we can just store that data URI, local storage, we can send it to someone, whatever.
Local storage is nice because then the thief's got the picture.
If they stole the laptop, you're in all sorts of trouble. Right, so let's have a quick look at my code for that. So we're going to take the snapshot. We've seen most of this, right? Using the full screen API there as well. That's quite cool. So I like to eat my own dog food. And then regurgitate for your delight. So here we've got it. Yeah, we've seen most of this, right? We grab the thing, we draw it in. But here's the magic part, right? We create a variable snapshot data, and we do, now interestingly here, it's not the context that we're grabbing the data URI of. It's canvas to data URL, and we tell it what format we want. Image ping, and then we create a generated date there, and then we create a little simple object, and then we write it to window.localstorage.setItem. If you're not familiar with local storage, it's a really simple local database. You don't have to create databases, you don't have to create keys or indexes. You just set an item with a key that you can make up on the spot, and most importantly though, it only stores strings. So here we created a little object, so we just stringify our object and then store it in local storage, right? So there you go. What have we done? Detected motion. We've started the video camera. We've captured a snapshot onto the canvas. We've grabbed that as a data URI, and we've stored it in local storage. And we could send it to, we do a heap of stuff with it. Just a couple of little worthwhile gotchas. So get user media currently needs vendor prefixing right across the spectrum. So basically there's a little bit of code that will do that for you. Currently supporting Mozilla, Chrome, Opera, and BlackBerry 10. So it's getting there. Currently not supporting iOS devices, not supporting Safari, which is a bit of a bummer. We'll have to see how that goes. They're probably the really strong holdouts. Not supporting Internet Explorer. Again, we'll have to see how they go. Right? The URL object, so window.url, which basically you can create a URL object and you can revoke it. That's what you can do with it. Right? It's supported pretty widely now, pretty much all modern devices, and including the most handheld devices and tablets and things like that. Only WebKit needs the prefixing, right? So you do window.webkiturl.create object URL, or URL object, one of them. I can't remember. It's a detail. And finally, device motion. You don't need any vendor prefixing, which is kind of cool. It's really widely supported on desktop, on laptop devices. Internet Explorer 11 Plus supports it. Opera 15, which is pretty much Chrome, certainly at the moment, and probably will for the foreseeable future. Android from 3 and iOS. Firefox, I saw a recent claim that they did, but I haven't actually kind of verified that. So basically, the intersection of all these technologies isn't super great. It's a bit like the intersection of people with SydJS and people who care about rugby league. Very small. The intersection of all these particular technologies, it's a relatively small subset. So what I'm talking about tonight isn't something going to run on every device ever, but I guess it's an example of the sort of, hopefully, slightly non-intuitive things we can be doing with web technologies. And lastly, that's me. You may follow me or just tweet me or whatever you like. And for those who don't know, although although you will, so one of the things I do is run a thing called Web Directions. So it's on in Sydney in late October. We have a whole developer-oriented track, which is a heap of awesome HTML5 and JavaScript stuff. At the moment, the people we can confirm, and some other really cool developer people coming, but Andrew Betts, who ran the project that built Financial Times HTML5 app, and he's going to talk about how you make HTML5 apps run like native apps, deal with all the performance challenges. Everyone, I think, in the world knows Alex Rauschmeyer. He's awesome JavaScript guy, so he'll be coming out and he's going to run a workshop. So if you're a good JavaScript developer and want to be a great JavaScript developer, he's your man. And of course, everyone knows Dimitri. He's going to be talking, although I misspelled his name, he will kill me. And when I mean he will kill me, he actually could kill you. And there's a heap of other developers, some people in this room are speaking, and awesome stuff like that. So please, we'll send it around later, but there's a SydJS discount code, just jump on that. But meantime, thank you very much. Hope you enjoyed that. I don't know if we've got time for questions.
Do we have any questions?
Anyone got any questions? Oh, right down the back.
2 questions.
Yes, Les.
How vigorously have you tested it, and what's your address?
My house. Ironically, where I live in this kind of really remote hamlet where no one actually locks their doors or anything. It works pretty well, actually. I wouldn't want to. flaws like this were detected easily. If you on a concrete, really strong concrete floor, probably wouldn't, but anything with wooden floors, any floating floor like that, you'd be surprised how sensitive they are.
If you have a concrete floor, just put a sign out, only heavy set burn.
Yeah. Yeah. Well, then we got to, well, the other option potentially is to actually grab the video stream and do some movement analysis, which is, there's a JavaScript library for that. It's pretty trivial stuff. That's how that Mac app that was running in our office that I alluded to right at the beginning was working, because those old iMacs didn't have gyroscopes. So they must have been just doing a bit of, there's a heap of libraries that will just do diffing analysis and you can decide whether or not someone's moved and so on. I reckon the false positives with that, I don't know, I'd be interested to see which ones kind of give you worse false
research paper on detecting kittens. So
yes, detecting kittens is very hard. We don't have a kitten. Have children though.
Slim modes too.
Which was that?
Canvas supports slim modes too, so it's easy when they're
That's it, yeah, no, you're right. It's even easier, because you used to have to do it pixel by pixel, but now you can just do it in blend modes. Oh, awesome. How good. All right, well, thank you very much.
Can we thank John?
Thanks,
please?
guys.